a tutorial for getting started with Atmos, and I kind of wanted to go through this somewhat in a, just kind of talking through it fashion. You could go and do this yourself. But I think, just showing the high level view of what this tool does and what it enables is really useful. So I'm going to open up, we have our tutorials repository. So that's another thing to show alongside of the tutorials that we have on docs.cloudposse.com. We also have a repo with a bunch of code. So we're going to be going through this one here, and I'm not going to follow it step by step. I'm kind of just going to loosely talk through it while executing some of these commands. But if we're in our tutorials repo and we just do, I've got that up here locally. If we run make run, what it'll do is it runs our tutorials image, which is, for any of you that know geodesic, it's built on geodesic, and basically allows us an automation shell with all the tools that we would need, including Atmos, that will allow us to work on this environment without all the problems of, hey, it works on my machine, doesn't work on somebody else's machine. So I'm just going to run this simple make target, which is going to bootstrap that container for me, which I have locally, this Cloud Posse tutorials container, and it's going to mount this this directory, this tutorials repository, into that container. So, it's a little big, so you don't get the I forget what this is called, the like nice looking thing, but maybe it's fine now. Anyway, so this is our tutorials toolbox. That's what we're calling containers that are built on geodesic as toolboxes. So now, we have, we're just in a regular shell on this container, and we have our tutorials directory here at the root. So I'll just cd into that and cd into our specific tutorial. So this is the Atmos tutorial. So in this directory, we've got a few folders, and I'll go back to my editor to kind of walk through these. We've got a components directory here that has a number of Terraform root modules. So a component is, there's a bunch of shared components that are reusable root modules, so that you don't need to like reinvent the wheel to create a VPC and a bunch of subnets or something along those lines. We've made some like contrived examples as part of this tutorial that we're going to show, which, this one uses your IP address to fetch your location. And then it uses your IP information to go and fetch the weather data about your location. And then it, very simply outputs it to your terminal. So, what you can do with Atmos is, if we just check out Atmos help, we can see some of the cool stuff you can do. But you can work with a few things. Atmos supports Terraform and Helm file as its main components that it works on, and it also works a little bit with Helm and soon to be Vendor and a few other tools like Istio. But the main thing that we're going to look at is Terraform stuff, because I think a lot of the people from the Cloud Posse Suite Ops community are really Terraform is king, right? So if we use Terraform, we can use Atmos Terraform to automate some of the simple stuff. And we'll just do a simple plan here where we'll do Atmos Terraform plan, and then we give it the component that we want to plan, like fetch location, and then we provide it a stack. So I have, I was saying earlier, a stack is a YAML configuration that allows you to kind of piece together various components, and Atmos natively understands that YAML configuration schema. And here we just simply list and provide one input for our components that we're working with here. But we list our fetch location component, fetch weather, and output results. So if we specify our fetch location our stack is actually example, and Atmos knows that, hey, our stack is going to be specified in our stacks folder. So we'll do this Terraform plan, and what Atmos will do is it starts from nothing. So it'll go and run a Terraform init, which it does here, and then it will create a workspace for you, and then it will run your plan. And yeah, that's pretty simple. Also, we could have just CD'd into that directory and run a Terraform plan, right? Like we didn't provide any value by doing this. So we can see that, hey, we're able to run a plan via Atmos, but what is that actually doing for me? The main thing that it really allows us to do is we can specify all of our configuration for these root modules that or these components that we're defining and we're using. And also we can do something cool called workflows. So I'm going to show a workflow real quick where we can specify a set of jobs that we want Atmos to do, and then it will go through executing those various jobs. So if I run Atmos Workflow, and I'm going to actually look at the help because I don't know it that well. So you specify a workflow, and then you have to specify a stack. So I will do Atmos Workflow, and then we want to do the deploy all workflow, and we will specify our stack. So our stack was example. And what this will do is it'll start going through and executing these Atmos commands in order that we specify. And this enables us, hey, if you follow Terraform best practices of breaking up your root modules, you can now orchestrate them in a really kind of streamlined fashion to help you be able to automate a lot of the pieces, the glue that you might have to write specific configuration around, or specific pipelines around, rather. So instead, now, executing this workflow, we go through, it does a Terraform plan, and then it will immediately apply that. That's what our Terraform, Atmos Terraform deploy command does, is it will plan and apply. So it planned and applied, it created our fetch location root module component that gave back this output information that says, hey, I'm in Boulder, Colorado in the United States. And then our next step, which was fetch weather, uses remote state from that previous component. So it needed to be executed in this fashion because it didn't have the information previously. So it'll go and look up like, oh, I know you're in, because you executed fetch location, I know, you're in Boulder, Colorado. So I'm using remote state from there. And now I can find your proper location and then look up the weather for that. So it'll give me a weather report for that area. And then the last component that we execute is our output results component, which has a variable that we define, and it passes that from our stack configuration here. And that does Terraform init as before, does a plan, and then finally goes through and prints out the weather. This is a super contrived example, but the idea here is that it's showing how you can build on top of root modules and orchestrate them and enable you to define all of that in one location, right? Like this stack configuration file. Eric mentioned, I'm using this with my own clients. I really love this because before, the way that you'd follow best practices, you'd break up all your root modules and so that you have less blast radius. But you don't have a great way of easily defining how those root modules connect or one place to define all the configuration for that. It kind of ends up being this tribal knowledge issue. When you have stacks, that goes away. And this is a super contrived example of what this looks like in regards to a very this isn't what you would normally use Terraform for, right? This is us, looking for an easy way to not have to enter AWS credentials. But if we go and look at a more real stack, and this is just something I put together, this is something that you might use for an AWS account. So we have a US West 2 prod YAML stack that defines a bunch of Terraform components. It has shared, it supports some Terraform null label values like stage and environment and all that stuff. Actually, my environment here would be US West 2, so that the naming for all of my resources would be really consistent. But I define a bunch of components, root modules that I have locally in my project, and this is again just an example. But via this stack pattern, I can define, hey, I want CloudTrail to be watching this account. Hey, I want a VPC with this sitter block. Hey, I want a Postgres database. I want a delegated DNS hosted zone in this account. And I want an EKS cluster running version 1.19. And defining this all in one central location instead of it being spread out across either a bunch of pipeline code or a bunch of variable files that you have to then go and manually apply, or maybe they're sitting in Terraform Cloud or somewhere. Having this all centralized into one location has a lot of power. And also, we're not going to get too much into it. I don't use the Helm file stuff too much, but the stuff that Cloud Posse does in regards to allowing you to install Datadog, stuff into your Kubernetes cluster after that cluster is up, allows you to do things like, hey, I just want Datadog running. I want it to have these tags for this particular account, and then that enables, you're not just dealing with Terraform. You're not just dealing up until the Kubernetes dividing line, and then it's just, you deal with it in your own way. No, you're dealing with it from the perspective of, okay, we build all of our infrastructure, and then when our infrastructure is up, what does our application layer look like? Or the surrounding services before our application layer. So I think that that covers a lot of what I wanted to talk about in regards to Atmos, in regards to stacks. If you're interested in this stuff, we're still building out a lot of documentation, and I'm the one, writing it. And, I think that Eric and I both would love to see a lot of feedback or interaction with the community, because there's a lot of reuse capability here. One thing that's really awesome that I just remembered I really wanted to bring up is we have Cloud Posse has open sourced all of their components. So, and I'm going to the wrong address.
And this answers Emil's question. Can you show an example of those root modules, and how far is a component from a Cloud Posse module? And just to talk to that a little bit while Matt kind of pulls this up. Also, Matt showed all the 20 pull requests that we have open here, upstreaming more components. Like, we just have a treasure trove of components at Cloud Posse. The only thing preventing us from upstreaming more of this stuff is time. So, but the key thing here to think about, the difference between root modules and that we call components and Terraform modules, is that root modules, first of all, are the top level modules in Terraform. That's what has Terraform state. That's what persists to an S3 bucket or whatever your state backend is. And then we have modules. So modules, or as Terraform calls them, I think child modules, don't have specific Terraform state. Now, we write our Terraform modules so that they are less opinionated than your root modules. They're still opinionated in the sense that we always use null labels, so all of our resources are consistently named. But aside from that, we try and make them very just professional, very reusable, very generic, and very consistent. But our components are hyper opinionated. This is the Cloud Posse secret sauce that's not so secret anymore, that we're publishing out there. The components is how we actually build and architect our infrastructure in such a way that we get these building blocks. So when we think about a VPC, here's our VPC implementation. This is what we deliver to actual customers, and we've delivered this same version of this VPC, every year for the last 5 years, and it's continuously evolved and evolved and evolved until what you see here. Some things to note that will bite people in the butt: if you just try and use our components, but you're only trying to cherry pick some of our components, your mileage is going to vary. It's not maybe going to be that effective, because what our components do is that they're very pluggable with each other. So they're reading Terraform remote state. And if you look at one of these pull requests, Matt, like, let's see what's a good example there, because the pull requests are the most updated versions of these. So let's look at the Aurora Postgres component there, 313. And then why don't you click on the branch for upstream Aurora Postgres, and then go to the modules for that one. Oh, see.
Yeah,
I want to
go
see.
back.
Yeah. Yeah, and then go to there. Okay, so then you see, click on that remote state.tf file.
Yeah.
So this is really cool because we are using kind of this Cloud Posse Terraform framework that we have, or SuiteOps framework, is that, well, we understand what a stack is. We understand the convention. And anytime we want to get the outputs from any other root module in this framework, it's super easy. All we do is call this module for remote state, and it knows how to fetch the outputs of any other root module in this environment. That it obfuscates, or I mean, it abstracts away some of the challenges using the remote state provider, and it makes it easy for anyone else to use. However, if you're not using our stack configs, or you're not using our account module, or you're not using the way we delegate IAM roles and all that stuff, this is where it's not going to work that well with other infrastructures. And the way I talk about this to customers is that it's kind of like the metric system versus the imperial system. They're both great systems. You know, they both produce effective measurements and ways to construct nuts and bolts, but you can't take a metric bolt and use it with an imperial screw. They just don't work together. And that's what we have. So when you use Cloud Posse components, you should use as many as you can. And you should design your personal components that you have in your company to kind of follow some of our conventions.
And I think that, for a new project, I plan on using these. For existing projects where I'm still using stacks, I'm still using this methodology about thinking about things. What I do is I copy, what Cloud Posse has already shipped to multiple clients of theirs that is already, open source. And, I'm able to make a breadcrumb trail back to the open source module, or the open source component. And then I just edit it down to what works within my client's environment. And that enables me to, not have to think about how to, it basically makes it so that I can pull a root module off the shelf. I need to edit it a little bit because I maybe don't have the remote state that component requires, but it allows me to bootstrap a big piece of functionality that I might add for a client without needing to do a bunch of thinking myself, or, playing with all the knobs and dials to make it tuned to the correct amount. So yeah, these are super useful, but it's not all or nothing, but if you're not using all, then you need to edit them a little bit and make them fit to your use case, but there's still a lot of value there. Anyway, anything else?
That's really great overview, Matt. I like that.
Cool. Anything else we should chat about, Eric, in this regard, while we're here?
Yeah, well, just to emphasize one or two more things. One is that you can use Atmos without using any of our components. Our components is how we think about infrastructure as these building blocks. And the desire there is that we, as contractors going into engagements, really don't always know every situation that we're going to encounter. So what we've tried to do is build something where it addresses almost every single situation that we've encountered, even those that we haven't yet encountered. One customer wants 25 VPCs in one account. Okay, no big deal. One customer just wants one VPC per account. Great, we can do that. You want 2 EKS clusters or 3 EKS clusters in an account. No big deal. So the architecture can be expressed fully with configuration based on the way that we decompose our components and separate the configuration from those. So I think I want to point that out. One other thing is that this YAML config format is, Atmos reads it, but anything can read it. It's just YAML. So we have actually a Terraform module for Spacelift that will then Terraform out Spacelift so that it'll run Atmos or read the Atmos stack configurations. The same thing more or less could be done with Terraform Cloud, but we've had a little trouble with working with Terraform Cloud and some of the limitations there. So I don't know what the current state of that is. All right, that's all I wanted to add.
Yeah, I think that's like a good point or good points. To pull what you're talking about, just to mention it. So if folks are interested in diving deeper, I think that, I don't know, I'm interested, in always diving deeper in this stuff, because it's useful to know the open source stuff that you're using. How is it built so that you can, debug it, but also, what's the secret sauce? What are you actually providing? I think that the provider utils, so there's this module, which Eric just mentioned, which actually is what defines that stack, or what actually reads in that stack, rather. And the reason why that's its own module and not just a, hey, YAML decode, is because that YAML parsing, when you're getting it to the scale that Cloud Posse has pushed it to within Terraform, it's ultra slow. So I think Matt from your team,
Matt
Calhoun, yeah, he, all your senior guys have contributed here, obviously, but this provider is one of the lower level things that's like the stack configuration is building on top of to make that YAML parsing fast. And it's just providing some simple data sources that make it so that you can do that YAML parsing, or that YAML parsing happens at the Golang layer and not at the Terraform layer where it's ultra slow.
Yeah,
and it supports deep merging, which is
something you
can.
Deep merges, yeah.
That's actually
maybe I was thinking it's the slow part, but yeah, sorry,
It's
go ahead,
both.
Matt. Yeah.
No, that's all I was going to say. Is the tricky part was the deep merge, not necessarily the speed of parse.
Yeah, and the generated code you folks had gone through, I saw Andre's work on that, where it was originally there was a bunch of goofy ways to generate Terraform code to deal with that, so you could go 20 levels deep or whatever it is. Funny stuff.
Anyway, we didn't even mention imports, did we?
Oh no,
or no,
let's
imports.
jump into imports. Cool. So we were just talking about Atmos with this very contrived example. I think that one of the things we can do is look at in our third tutorial, where we actually build a AWS environment. We actually have some more involved catalogs, and they're still fairly simple. We build a static site. It's an S3 bucket with a CDN in front of it. But the thing that's useful here is, or useful to show, is that, hey, if you have stacks that run in different environments, or you have globals across all of your stacks, things like if you have the same backend configuration. So one of the things that Atmos allows you to do is you define your backend configuration within your stack, and then you can have Atmos generate the backend config Terraform file for you, so that you can check it into source, follow GitOps, and you're always going to be pointing all of your components to use, all of your root modules to use the same Terraform backend. And that's kind of a tangent, but let's say you always have the same namespace across all of your components, or you always have the same region or environment variables, then you can use the stack import, the import key value to specify what you want to import. And that enables you to create very dry and reusable YAML configurations for your stacks, which I think it ends up being really critical, because if you had no possibility to do import when you're managing 5 environments across multiple regions, across with dozens and dozens of variables, it ends up that you repeating a ton of configuration all over the place. And with imports, it does a deep merge. So it'll import the document on top of what you're importing it to. And then you have the ability to share configuration across the board. We need to update our reference architecture. The Cloud Posse reference architecture will show this very well soon. But right now we don't have a great example, unfortunately. This is the best I can probably show where, hey, we're showing, there's US West 2 globals and just general globals, but there's also component globals and all that fun stuff too. Emil, I think is that?
Yeah, I do have a question. Like, yeah. If, like, say you instantiate 2 times the VPC, like I saw like there was one example that has VPC1, VPC2. Does it mean like you're gonna have 2 state, basically, one for each VPC, and then that's gonna like, how does it? Okay, so it deals with that, because I saw like it does an init, but like if you do an init with another state, how does it work?
Oh, so we can show component inheritance. So
virtual
like
component,
static, virtual components. So that's also a really cool thing we can do.
Yeah. So this is in our stacks configuration. I'll post this because I think this is some useful information. And sorry, I'm not following along with the chat, so I hope I'm not missing a lot of stuff. But in the idea where you have 2 VPCs. Right, your VPC name would end up, what the workspace name it creates is the stack file name and then the component name, and that ends up being your workspace. So something speaks to that.
Workspace in the sense of like cloud, Terraform Cloud Workspace, or in the sense of a workspace, Terraform Workspace, because those are
Terraform Workspace.
Okay,
Terraform so the CLI workspace and not the
CLI.
A separate state file for that. Yeah.
Uh-huh.
So here's an example of that. So the name individual environment stacks file. Oh no, that's not. Anyway, so what you asked about though is like, hey, how does it work in regards to specifying 2 VPCs? And there's an idea there. We're calling it component inheritance. There's a few names kicking around, but the idea is if you have multiple S3 buckets, for example, that you're creating, then you would specify the top level name as something different for each of them, but then you specify the component that it's inheriting from as component. So, this shows imports actually pretty well where, in our stacks folder, we have a catalog folder. This is where all your, shared configuration goes. And then you have a component S3 bucket.yaml. And this gives you, the base configuration for your S3 bucket that will be shared across all S3 buckets that you create if you're doing an import. And then in the concrete implementation of using that component, you specify a unique name, and then you just specify the component that you want to base off of that name. So not a common use case, or no, it does come up a lot, but it is something where you're, I don't know, I lost my train of thought, but you're basically dealing with them at a higher level.
So what I would say is your job, in operations is establishing a platform and the best practices. So what you're going to be doing is creating this library of reusable component definitions, or these snippets, and you stick those in the catalog. So you create a snippet for an S3 bucket, you create a snippet for your EKS cluster, you create a snippet for your RDS Aurora Postgres database, your ActiveMQ clusters, your Redis clusters, all that stuff. You create a huge catalog, every service your company wants to deploy. Now, as a developer, I come in, all I do is when I want to create a new environment or new stack, I just use these imports. Okay, look, I want an S3 bucket, I want an EKS cluster, I want an RDS, a Redis database, etc. And then down here under components, then I just override what I want to extend or what I want to set differently. And here you can say, well, what if I want 2 buckets? I don't want just 1 bucket. No problem. Just specify public images. In the first one, say that it's based off of the S3 bucket component. Then below that, we created the export data, also based off the S3 bucket. Yeah, and then you notice for one, we changed it from ACL private, which would be the default, to ACL public, since it's for public images. And that's it. Notice we didn't need to touch a line of Terraform code. We can reuse those components as many times as we want. So the cool thing here is that once you have a sufficient library of components in your organization, you get out of the business entirely of writing Terraform every time you want a new environment or thing like that. You're just dealing with configuration. Our configuration is also designed to, it doesn't do fancy stuff like loops and iterators and interpolation, because ultimately our configuration should just be exactly what we want our architecture to be. Anything that needs to be computed, that's the job of the Terraform or the component underneath it. So that's why we don't think in our configuration we need anything fancy.
I think I just came up with a new quote, Eric. Terraform wasn't declarative enough. It's its own language, right?
Yeah.
So
exactly.
the idea with stacks and components is that you're truly just declaring what you need, and your business logic, the actual logic that builds 50 ECR repos or whatever it is all in Terraform, and then the YAML is what is actually defining what's going to go live.